All right, section 10.1 is radical expressions and graphs. All right, so finding the square root of a number, for example, if I take the square root, it's what times itself gives you the number under the radical. So for example, if we want to find all the square roots of 49, that means what times itself gives you 49. So I could have 7 times 7, that equals 49. So the square root of 49 is 7. But I could also have negative 7 times negative 7, because negative 7 times negative 7 is 49. All right, so all the square roots of 49 would be 7 and negative 7. All right, now if you're looking for a positive or a principal square root, you would only give the positive value. So for example, the square root of 121 is 11. So if it asks for the positive or the principal square root, you only give the positive value. If it asks for all the square roots, you would give the positive and the negative value. Okay, so this whole thing is called a radical. The symbol here is called a radical symbol. So it could be a square root. If you have a 3 there, it would be a cube root, or it could be a fourth root, so on and so forth. That is the radicals, excuse me, symbol. And then the number that is under the radical symbol is called the radicand. And this whole thing is called a radical expression. Okay. All right, so when you're finding the square roots of a, the square root of a would be positive if you're trying to find the principal or the positive square root. But if you have a negative in front of your symbol, that would evaluate to a negative, because you would just cancel your, carry your negative over into your answer. So for example, if we want to find the square root of 144, we know that that is 12. 12 times 12 is 144. But the negative square root of 1024 would give me a negative value, because you would just carry that negative over into your answer. So what times itself gives you 1024? It's 32. 32 times 32 is 1024. All right, now I know we are not supposed to use a calculator in this class, but I know that you all are probably using it. But if you're not using a calculator, you could do a factor tree and break this number down and then find what the squares are. All right, the square root of 4/9. You would take the square root of the numerator over the square root of the denominator, so that would be 2/3. The negative square root of 16/49, of course you would carry that negative over to into your answer, so that would be a -4/7. All right, what times itself gives you 0.81, and we know that that is 0.9. Let's do one more. The square root of 0 we know is 0. 0 times itself is 0. All right, we want to find the square of each radical expression. So here, the square root of 13, if we square it, it'll be the square root of 13 squared. Whenever you square a square root, that's just the opposite. And so the radicand would come out of the radical, and that equals 13. The negative square root of 29, you would square that. When you square a negative, you get a positive. What is underneath the radical comes out. So that would be a positive 29. All right, if you square the square root of p squared plus 1, what is underneath the radical comes out, p squared plus 1. Sorry. All right. The next example is where we will classify each square root as rational, irrational, or not real. Not real meaning complex or imaginary. So let's kind of go back through and I'll explain what each one is. So we know that real numbers, we'll just start there. Real numbers consist of rational and irrational numbers. Okay, and so rational numbers consist of natural numbers. So those are your counting numbers like 1, 2, 3, so on and so forth. Whole numbers, which would just include 0, 0, 1, 2, 3, so on and so forth. Integers, and we know integers are the negative and positive whole numbers. So -3, -2, -1, 0, 1, 2, 3, so on and so forth. And it also includes fractions, anything that you can write as a fraction. So, for example, 1/2 is the same as 0.5, and that is a terminating decimal, so you can also include those in rational numbers. Or something like 1/3, which is 0.33333 repeating decimal. So those are also included in rational numbers. And then irrational numbers would be a non-terminating, non-repeating decimal. So something like pi which is 3.141592, so on and so forth. It does not terminate and it does not repeat. Or if you take the square root of a non-perfect square, so something like the square root of 2, square root of 3, square root of 7, square root of 5, square root of 11, any non-perfect square. That would be an irrational number. So let's see, what is the square root of 2? I don't know it right off the top of my head. It is approximately 1.41421, so on and so forth. So these are non-terminating non-repeating decimals. Okay, and then anything that is not a real number is a complex number. So we also call these imaginary or non-real. Okay, and that's when you have a negative under your radical. So something like the square root of -4. Well, we know the square root of 4 is 2, but because I have this negative under the radical, it makes it imaginary. So I'll say that that is 2i. Or the square root of -25 would be 5i. Okay. So now let's look at, well, actually, let me explain one other thing here. So if you have a negative under your radical and it's an even root, so this is a square root, or if I'm sorry, let me tell you what I'm saying. So this is a square root, so its index is 4. But I'm sorry. Stop. Its index is not 4. Its index is 2 because it's a square root. Sorry. Okay. So if I had the fourth root of, say, -16, that would be imaginary. That would be 2i because the root or the index is even. But if I had the fifth root, so for example, the fifth root of -32, that would equal -2 because there are 5 numbers that you would multiply together to get the number under the radical. So if it's even, it's an even index, like a 2 or a 4 or a 6 or an 8, it would be, and you have a negative under the radical, it's imaginary. If it's an odd index, then it is not imaginary. So this would be considered a rational number, and these would all be non-real. Okay, so let's look at an example. Okay, so we want to determine whether each square root is rational, irrational, or non-real. So the first one is the square root of 17. This is a non-perfect square. So that would make this one irrational. You would get a non-terminating, non-repeating decimal. Okay, the square root of 64, we know the square root of 64 is 8. So that would make this one a rational number. The square root of negative 25. My index is even because this is a square root. So this one would be what? Sorry, let me write here. Even index with a negative under the radical. That would make this non-real. And what does it equal? It equals 5i. It didn't ask you to say what it's equal, but just so you'll know.